Welcome to our lesson on chemical formulas. Today we'll learn how to determine if chemical formulas are correctly written based on their charges. Let's look at this multiple choice question. Which pair of chemical formulas is correct? Option A, silver carbonate and ammonium nitrate. Option B, potassium bicarbonate and zinc phosphate. Option C, silver bicarbonate and potassium phosphate. Option D, zinc carbonate and ammonium phosphate. To solve this problem, we need to check if the positive charges from the cations balance the negative charges from the anions in each formula. To determine if a chemical formula is correct, we need to make sure that the total positive charge from cations equals the total negative charge from anions. In other words, the sum of all charges must be zero. Let's start by reviewing some common ions and their charges. Here are the charges for the ions in our problem. Silver, Ag+, has a charge of positive 1. Potassium, K+, has a charge of positive 1. Zinc, Zn2+, has a charge of positive 2. Ammonium, NH4+, has a charge of positive 1. Carbonate, CO3 2-, has a charge of negative 2. Bicarbonate, HCO3-, has a charge of negative 1. Phosphate, PO4 3-, has a charge of negative 3. Nitrate, NO3-, has a charge of negative 1. Let's check option A, which has silver carbonate, Ag2CO3, and ammonium nitrate written as NH4 3NO3. For silver carbonate, we have two silver ions, each with a charge of +1, giving a total positive charge of +2. The carbonate ion has a charge of -2. Since 2 positive equals 2 negative, the charges balance out, and this formula is correct. For the second formula, NH4 3NO3, we have 3 ammonium ions, each with a charge of +1, giving a total positive charge of +3. The nitrate ion has a charge of -1, so we have a net charge of +2, which means this formula is incorrect. The correct formula should be NH4NO3, with just 1 ammonium ion. Moving on to option B, which is potassium bicarbonate, K2HCO3, and zinc phosphate, Zn3PO4 2. For potassium bicarbonate, we have 2 potassium ions, each with a charge of +1, giving a total positive charge of +2. The bicarbonate ion has a charge of -1, so we have a net charge of +1, which means this formula is incorrect. The correct formula should be KHCO3, with only 1 potassium ion. For zinc phosphate, we have 3 zinc ions, each with a charge of +2, giving a total positive charge of +6. We also have 2 phosphate ions, each with a charge of -3, giving a total negative charge of -6. Since 6 positive equals 6 negative, the charges balance, and this formula is correct. Now let's check option C, which has silver bicarbonate, AgHCO3, and potassium phosphate, K3PO4. For silver bicarbonate, we have 1 silver ion with a charge of +1. The bicarbonate ion has a charge of -1. Since 1 positive equals 1 negative, the charges balance out, and this formula is correct. For potassium phosphate, we have 3 potassium ions, each with a charge of +1, giving a total positive charge of +3. The phosphate ion has a charge of -3. Since 3 positive equals 3 negative, the charges balance out, and this formula is also correct. So both formulas in option C are correct. Finally, let's check option D, which has zinc carbonate, ZnCO3, and ammonium phosphate, NH4 2PO4. For zinc carbonate, we have 1 zinc ion with a charge of +2. The carbonate ion has a charge of -2. Since 2 positive equals 2 negative, the charges balance out, and this formula is correct. For ammonium phosphate, we have 2 ammonium ions, each with a charge of +1, giving a total positive charge of +2. The phosphate ion has a charge of -3, so we have a net charge of -1, which means this formula is incorrect. The correct formula should be NH4 3PO4 with 3 ammonium ions. After checking all options, we can see that only option C has both formulas correctly balanced. Let's review our findings. Option A. The first formula is correct, but the second formula is incorrect. Option B. The first formula is incorrect, but the second formula is correct. Option C. Both formulas are correct. Option D. The first formula is correct, but the second formula is incorrect. Therefore, the answer is C, silver bicarbonate and potassium phosphate. Here are some helpful tips for balancing chemical formulas. First, always identify the charges of all ions in the compound. Second, remember that the total charge in a neutral compound must equal 0. Third, use subscripts to indicate the number of each ion needed to balance the charges. And finally, when writing formulas, cations usually come first, followed by anions. With practice, you'll get better at quickly recognizing correctly balanced chemical formulas.